In the next example, we have a cone that is increasing in size. So that means the dimensions of the cone are dependent on t, or change with time. Here's the formula for the volume of a cone. So the volume of a cone is given by 1/3 pi r squared h. This is r, the radius of the bottom, and h is the height. Now we have this little side relationship that tells us that in this cone, h is twice r. H is equal to 2r. And we're asked to find an equation that relates dv dt and dh dt. Well, if we differentiate them, we are going to involve r, but we only want dv dt and dh dt, so what we're going to do first is the eliminate step. And we want to eliminate r, so that'll be our first step. And in this case, we want to eliminate r. All right, again, we do the eliminate step when we have three variables, like in this equation, v, r, h. Eliminate the one that we're not interested in. Okay, so if we want to eliminate r, well, h is equal to 2r. We have to solve for r. Okay, so r is equal to h over 2. Let's take that volume equation and let's just put h over 2 right here. So we have v is equal to 1/3 pi h over 2 squared h. So that's 1/3 pi h squared over 4 h. All right, that let's multiply the 3 and the 4 and put the pi on top. So that's pi over 12. And here we have an h cubed. All right, that's our eliminate step. And now to get an equation relating dv dt and dh dt, we're going to be differentiating. So let's do that. So we'll take our formula that has r eliminated, and that would be v equal pi over 12 h cubed, and now differentiate. dv dt is equal to pi over 12 3h squared dh dt. Okay, so that's basically it. We could just reduce a little bit, divide by 3. Okay, and we have pi over 4 h squared dh dt. Okay, so let me just rewrite this. And that's our equation involving dv dt and dh dt. Number 5 also involves a cone. And so we'll be needing the volume of a cone. Let me just remind you of that. Let me write it down here. V is equal to 1/3 pi r squared h. So this says that gravel is falling onto a conical pile at the rate of 100 cubic feet per minute. That means that gravel is falling on this, gravel is falling and maintaining the shape of a cone as it falls. Okay, so you have gravel falling here, maintaining the shape of this cone. The rate at which the gravel is falling, that will be the same as the rate at which the volume is increasing. So that would be 100 cubic feet per minute. So we're told that dv dt is 150. All right, now let me remind you that's the height, and there's the radius right there. So we're told to assume that the height is equal to the radius. So as the gravel falls, it maintains that same proportion of the height equal to radius. So that's our side equation that we'll use to eliminate the variable that we're not interested in. Okay, here, find the rate of change of the height. So we want to find dh dt. when the height is 5, when h equals 5. Okay, so we're going to work with this with volume formula. And notice it involves three variables, v, r, and h. So before we differentiate, we're going to have this eliminate step. So that will be step 1. We're going to eliminate the variable that we're not interested in. Well, since we're asked to find dh dt when h is equal to 5, we want to eliminate r, since r is not mentioned here. Okay, so let's eliminate r. Well, it's going to be pretty simple because h is equal to r. All right, so here, right here, instead of r, we're just going to put an h. So in the eliminate step, again, we're going to eliminate r. We write v is equal to 1/3 pi, and h is equal to r. So here we have h squared h. Okay, so v is equal to 1/3 pi h cubed. All right. And now we want to get an equation that involves the dv dt and the dh dt, so we're just going to differentiate our volume formula with r eliminated. Okay, so we have dv dt is equal to 1/3 pi 3h squared dh dt. Okay, these threes cancel. And finally, in order to find dh dt when h is equal to 5, we're just going to substitute. All right, so that's the last step, the substitute step. All right. All right, so we'll substitute right here into our equation involving dv dt and dh dt. So here we have pi h squared dh dt. So we have dv dt is 150 that we were told. And we want to figure out what dh dt is when h is equal to 5, so we substitute that value. Okay, so we have 150 equal 25 pi dh dt. And then just divide, and then, okay, and then that'll be it. So we have 150 over 25 pi, that's equal to dh dt. Okay. And reduce that, and so we have 6 over pi. And the units here are feet per minute. Sorry, let me just check on the units. Right, so the units are feet and minutes, so dh dt would be feet per minute. Number 6 is another cone problem, so let me write down the volume of a cone. Okay, so a conical tank with vertex down. So this time the picture looks like this. The vertex is down. Is 12 feet across the top, so from here to here it's 12. And 16 feet deep, so that would be 16. Okay, so this is a tank, and it's being filled with water, and it says water is flowing into the tank at the rate of 10 cubic feet per minute. So let's picture the water in the tank. Now it's the volume of the water that's changing. The tank, of course, is the same size, so the variables R and H applied to the volume of the water. Okay, so there's our R, and there's our H. And it says that water is flowing into the tank at the rate of 10 cubic feet per minute. So that means that dV dt is equal to 10. Find the rate of change of the depth of the water. So that would be find dH dt when h is equal to 8. So we're going to do this like we did the other one. We want an equation relating dV dt and dH dt, so we want to eliminate r. Once we eliminate r, then we'll differentiate. Okay, but how do we eliminate r? We don't have that side equation. What we do have are these dimensions, 12 and 16. All right, and that'll give us a little proportion equation that will enable us to eliminate r. A little proportion equation that will relate r and h. All right, if this diameter is 12, then this radius is 6. Okay, and let's look at this. Let's look at these two triangles, this large one and this small one. Okay, let's draw it out here, say. All right, so the large triangle has dimensions 6 and 16, and the small triangle has dimensions r and h. These two triangles are similar. That means their sides are proportional. So that gives us our equation. So we have 6 is to r as 16 is to h. And now we can cross multiply, and we have 6h is equal to 16r. Okay, we want to eliminate r, so we'll solve for r. So r is equal to 6h over 16, which is 3h over 8. Okay, so that's r. So that's a little equation that we need to eliminate r. So now we're ready for the eliminate step. All right, so we have, starting with volume, we're just going to put, instead of r, we're going to put 3h over 8. So we have that the volume is equal to 1/3 pi 3h over 8 squared h. Okay, just simplify this. That would be 9h squared over 64. And then we have the h over there. Okay, let's divide the 3 into the 9. Okay, so here we have pi over 3 pi over 64 h cubed. So here is our simplified volume formula. V is equal to 3 pi over 64 h cubed. So we eliminated r. So we finished with the eliminate step. And now we're going to do the differentiate. So we'll have something relating dV dt and dH dt. So let's do that. dV dt is equal to 3 pi over 64. And then we have 3h squared dH dt. Okay, just multiply the two 3's together. So we have 9 pi over 64 h squared dH dt. Okay, and that's dV dt. So that's our equation relating dV dt and dH dt. And we're going to use this in the last step, the substitute step. That's always the last step. That gets us the solution that we need. Okay, so remember we want to find dH dt when h is equal to 8. So I'm just rewriting this over here. dv dt is equal to 9 pi over 64 h squared dh dt. Okay. Now remember, dv dt is always 150. We were told that. And we are interested in dh dt when h is equal to 8. So let's get ready to substitute. 150 is equal to 9 pi over 64 8 squared dh dt. That's 9 pi over 64 times 64 dh dt. Okay. Cancel those 64s, and we have 150 is equal to 9 pi dh dt. And finally, dh dt is equal to 150 over 9 pi. And that's the result that we were looking for. And the units are feet per minute.